I'm going to start the session. Yeah, is the audio okay before I proceed? Oh, cool. Thanks, everyone. Hope everyone's doing okay and having a good evening. So today we are going to cover Learning Unit 5, which is probabilities. All right, so let me share my screen. Take you through an example. All right, so if you can't see the whiteboard, just let me know. Otherwise, I'm just going to assume that you can. So, oops, what happened there? Chat. All right. So, probabilities. Okay, so a lot of you must have heard it of a probability at some point in your life. If anyone ever watched the weather at least once, they would have been exposed to a probability. So in the weather report, they'll say there's a 60% chance of rain tomorrow. Okay, and then another day it'll say maybe 80%. So the thing is, when you hear a report saying 80% versus another report that says say 50%, you're more likely to, if you had to listen to the one that said 80%, you're going to be inclined to think that you should carry your umbrella or dress for rainy weather tomorrow. And it's because of that value, 80%. It's a stronger probability that it's going to happen. All right. So what exactly does a probability mean? All right. So let's say if you're flipping a coin, a coin can either have a head or a tail outcome. Now the thing is, because there's only one of the two outcomes, so the probability of getting a head is 1/2. All right, so it's 1/2 for getting a head, and it's 1/2 getting a tail. Right, you have a 1/2 chance, or in other words, 50% chance. That's why they say 50-50, right? When you flip a coin. Now the thing is, if I flip a coin twice, right? So remember what we just said. We said that there's a 1 in 2 chance that you can get a head, right? So let's say I flip the coin in the first trial and I end up getting a tail. Now remember, we just said there's a 1 in 2 chance of getting a head. So you would think that for every 2 tosses, you're bound to get 1 head, because remember, that's 1/2, right? So that's the probability of getting a head. I'm gonna write like, let me just check the chat. No worries, okay? Okay, so I'm just explaining probability for flipping a coin. Remember, if you flip a coin, you can either take on a head or a tail, right? When you flip a coin. Now, we all can kind of accept this, that if it's a fair coin, if you flip it, the probability of getting a head is 1/2. So that means for every 2 flips, you're bound to get 1 head, right? Now, if that was absolutely true, then every time we flipped a coin the first time, okay, and say we got a tail, then we would, if we had to bet money on the second flip, we would assume that it's going to be a head, right? Because remember, it's 1 out of every 2 flips. But the thing is, life doesn't work like that, as you all know. You can flip a coin and you can get 2 tails. It can happen that you won't get a head. Even if you flip it 3 times, you can get 3 tails, right? So what exactly, how do we actually use this probability? Why is it even useful? If it's telling us that for every 2 tries, you're bound to get a head, but if you do flip the coin, you don't really get a head every second try. There might be a comment in the chat. Let me check. No. Okay. All right. So the thing is, probabilities do work, but they work when you have a large number of trials. So for instance, if I flip this coin, say 10,000 times, okay, so I'm not going to draw 10,000 lines, but let's say 1, 2, 3, oops, all the way to 10,000. So we started with 1 flip, 2 flips, all the way to 10,000. Now, if we had to do that, then this probability does work. It's a very good approximation. What would happen is, if someone actually had the patience to do this, you would find that out of those 10,000, half of them right? That's how we get this half of them. That means 5,000 of them would end up being, and I use this sign here because it's approximate. About 5,000 of them would be heads. So if it is a fair coin. So that's how probabilities work. They only work when you have an infinite amount or very, very large number of trials. Okay, so that's why if ever you hear a probability, even if you hear a probability that says, there's a 65% chance of rain, what it actually means is that if we had a large number of outcomes, by 65%, let's make it 60%, it's easier, right? 60% means 6 out of 10, right? So that means if there were 10,000 of these trials, right? If there were 10,000, then 6,000 of them would be days where it rained. Okay, so that's what a probability means. It actually works for a large number of outcomes, right? And the more outcomes you have, the more experiments or trials, the more accurate this probability becomes and the more useful it becomes. Right, does that make sense? That's how probabilities work. Let me see if there's any questions on that. All good? Or... All right. And in other ways, well, I'm sure everyone must have heard of casino. Casinos base the payouts of games on probabilities. And the reason why casinos can use probabilities very effectively is because they do have a large number of trials. Remember, there's not just one person coming in through the door and gambling. In a day, you could easily have a large number of people coming through the door and gambling. That's just one day. Give it a month, you're definitely going to exceed this number. It's very likely that a casino would have more than 10,000 people. That doesn't have to be different people. It can just be some person coming more than once, but he still constitutes, or she still constitutes as an experiment. So there's easily more than 10,000 in a month. So their probabilities do work. So they can say, okay, if the game is going to pay out towards us, the casino, 6 out of 10, then it's in our favor. They would allow this game to be in the casino, all right? Because they're bound to get it right 6 out of 10 times, which is so profitable for them, right? Versus if a game, however, had a 2 out of 10 chance, all right, or 1 out of 5 is the same thing. If it had a 1 out of 5 chance of paying the casino, that is 1 out of 5 chance the casino to win, the casino would not likely have that game in the casino because it's not going to be profitable for them. All right, does that make sense? This kind of gives you some sort of idea of how probabilities are used, and casinos are very big on using these. They're very effective. All right, let's begin. All right, so now that you have an idea of probabilities, let's take you through a kind of an example that you could get, or problem that you could get in your, I would very, very likely you're going to get something like this in your exam. All right, and I'll take you through how to solve it. Let's clear the board. Let's check if I'm recording. I hope I am. Yeah, okay, fantastic. All right, let's get back to the board. All right, so this is something that you could get presented with. This is a cross tabulation table. All right, so what a cross tabulation table does is it kind of shows two variables behaving with each other. So for instance, the two variables, the one variable is going down the rows, and if you look at the values going down the rows, if we just exclude this total cost, just exclude this, what you have here are what you call company positions. And you can be a director, manager, or a junior, right? So it's your level in a company. Okay, that's your one variable. And if you look at the variables that go across the columns, you got mining and finance, and that variable there is your industry sector. Okay, so for this example, you're only looking at two industries. right? That's the mining and finance. So you have these two variables interacting with each other. All right. So what the numbers in the table are telling you is that if you just look at the number 21 in this table, all right, the first row in the first column, it's saying that you have 21 directors in the mining sector, right? Then let's look at this 240 that we have here. What it's saying is that we have 240 juniors in the finance sector. The totals, now don't expect the totals to be done for you. You'll probably have to do that for yourself, right? So it's very simple. If you want to just know what the total amount of people are in the mining sector, just add up all the values going down the road. So 21 plus 80 plus 210 gives you 311, right? That's how you get the total. And if you want to get the column totals here, sorry, the row totals and for directors, you just add up how many directors are. 21 plus 40 gives you 61. All right, that's how you get this total. And then the grand total is adding up every single number in the table, and that gives you 751 people in total. Right? You'll need all these totals to work out the probabilities, so make sure you include them. The first kind of question that you could get is, what is the probability of being a director? Right? So I'm going to write it like a P bracket, and I'm going to write DIR instead of the whole word, just because I'm a bit lazy. So probability of a director, that's how I'm going to write it. Okay. Now to work this out, to work out the probability, just keep in mind these two things, right? It is, if you want the probability of anything, so we'll say a probability of an event A. Now, A can be anything, right? The probability of an event A is basically looking at how many times A can occur, so the number of times A occurs, okay, over the total number of occurrences. Now, let me explain. That means when you look at this example, so if you want the probability of a director, you would look at how many directors there are. So our event here, this A, in our case, is the directors. So how many directors do we have? We have 61. Okay, if you look at that, there's the total. We have a total of 61 directors. So 61, and the denominator is basically how many people there are in total, the total number of occurrences. So, or the total number of people in our sample for this one. So it's 751. And if you work this out, and you must express it as a percent, it'll be 58.59%. Try to keep it to 2 decimals. Okay, make it a habit. All right. So that's how you work with the probability of director. It's the total number of occurrences of directors. So how many directors do you have at 61 divided by the total number of possible occurrences or events. That is the total number of people, which is 751. And that's how you get 58.59%. I'm just going to pause it for a second and check if there's any questions. Oh, is everyone okay with this? To look at the probability of director, it's the total number of directors divided by the total number of people, which is the grand total, 751. All good? Science, okay. It's a government organization. All right, cool. So that's how you work with the probability of a director. All right, so let me quiz you on this one. All right, so that's how you work with the probability of a director. Looking at this table, what is the probability of being in the finance sector? So what is the probability of being in the finance sector? Can you give that a shot and write the answer in the chat? Remember, express it as a percent to 2 decimal places. You know what? I actually made a mistake. This is actually not 58.59. This is 8.12%. Please, I apologize for that. This is actually 8.12%. Okay. Work out the probability of being in the finance sector. What do you get? Yeah, that's why I react. So That's right. I see someone already got the answer in the chat. This one is actually 58.59%. This one is 50. And how you would have got that is the total number of people in finance, which is 440. You would have taken 440 divided by the grand total, which is 751. And that's how you got this. All right. Very good. Apologies for getting that number wrong for the directors. Okay. Well done. Okay. Glad to see you got this one. All right. Now, let's look at a joint probability. Now, a joint probability is simply just looking at two events occurring together. So an example of that is, what is the probability of being a director in the finance sector? What is the probability of being a director in the finance sector? So I could use the word and, but I'm going to write this symbol here for and. In statistics, you also find the symbol here, intersection. It's like a U, but it's like upside down. This just means and. So what's the probability of being a director and being in the finance sector? So what we do here is we look at our table and we look at how many directors intersect with the finance sector. So there's directors go across this way, and then finance goes down this way. So we have 40 people. That's where they intersect. We have 40 directors in the finance sector. So it'll be 40, and we divide that by the grand total once again, which is 751. And if you work this out, you should get a value of 5.33%. So that's an example of a joint probability, or where you have to use and, right? Intersection of two events. The symbol here is actually intersection. That's what it actually means. All right, cool. All right, now I'm gonna, this is another question you can get asked, and you'll have to use a formula for this one, and I'll explain it now. Let's say you are asked for the probability of being a director or being in the finance sector. And symbol for or is this like a U shape, all right? Union. That's what the symbol means. Union. Okay, it's just the same thing as the word or. Okay, now the formula you would use for this, and this formula is given to you in your formula sheet, so you don't need to memorize it. The formula in your formula sheet is for probability of A union B equals probability of A plus probability of B minus probability of A and B, or in other words, intersect B. So this is given to you. So all you need to do is, instead of using A and B, you need to use what the question is asking for. So you can let A be director and you can let B be finance. So you just use the same formula here. So that becomes probability. So we're going to go to the right side now and use this formula here. Oops. Okay, so that's probability A, which is director, plus probability of finance, because that's what our B is, right? Finance. I'm just going to write FIN for finance, minus probability of director and finance, intersection finance. So all I'm doing is I'm using this formula, but instead of A and B, I'm using what the question is asking me for, right? With A being director and B being finance. Now we've worked all these probabilities out, right? It's all on the left side of this panel here. Probability of director, we have it at 8.12%. So that's, we already worked that out. Probability of being in finance here, that's worked out as well. It's 58.59. And then the probability of director and finance is this here. So we have all the values, we just plug it into this equation and you get a value of, the final answer is 61.38%. 51.38%. Okay, so we're using the formula here to work it out. So remember, whenever you get the probability of something or something, you need to use this formula here. All right, it's in your formula sheet, so don't panic about it. I'll just pause it for a second. Is there any questions? Anyone lost? Very simple, or you need me to go through that again? Go through it again. All right. All right, cool. So let me just clear the board a bit, make some space. Okay, so I'm going to assume that everyone is good up until this point here, right? We're all good with these three values of how we got them. All right. Okay. I'm just going to make that assumption. Cool. All right. So now the next question is, they ask you to work at the probability of a director, being a director, or being in the finance sector. That's what the question is. Okay, this is what you're going to solve. Right. Now, in order to solve this, you have to use this formula, which is given to you. You don't have to memorize it, and you also don't need to understand how it works. You just need to know when to use it, which is for this kind of a problem. And that is the probability of A union B. And this union is the same thing as O. That's all it means, right? B equals probability of A plus probability of B minus probability of A and B, intersection B. All right, so we're going to use this formula here. I'm just going to put in a different color. Okay. Now the formula is given to you in terms of A and B, right? So it's a very general formula that you can apply to anything. So if you look at your problem, right, the one that they're asking you, this question here, they're asking you this question. Instead of having director, your director is actually your A. There's it here. You can let your A be director, and you can let B be finance. And if you do that, then you can just use the right side of the equation. And instead of using A and B, you substitute that with director and finance. And if you do that, then this right side becomes, okay, all I'm doing is I'm simply swapping A for director and B for finance. So it becomes probability of director, because I'm following the right side of the equation now. Probability of A plus probability of B is probability of finance. All right, and then this last part minus probability of director and finance, intersection finance. All right, so all I've done is, instead of A, I use director, instead of B, I use finance. Is everyone okay with that part? Fantastic, fantastic. And so that's the hard part done. Remember, now the value for each of these, you already did that previously. Probability of director is here. There it is. 8.12%. Probability of finance, we did that too. You did it in the chat. It's 58.59%. And the probability of a director and finance, so intersection finance, you did that as well. That was the last one we did, which is 5.33%. So you substitute all these values into the equation. And if you do that, then this becomes equals to, we do that in your calculator now. I want to see what answer you get. Okay, all you're doing is you're substituting these three values into this equation here, and write the answer in the chat. Yes, 61.38. Remember to express your, remember probabilities are always a percent, okay? So don't, if you write this in your exam, if you write 61.38 and you don't put the percent, you'll get marked wrong. Because remember, a probability cannot be more than 100%, all right? And also you can't have a negative probability. So the lowest the probability can be, is 0%, and the highest it can be is 100%. Keep that in mind. All right, if you get a value out of bounds from these, then you made a mistake somewhere. All right, you can never have a negative probability, and you can never have a probability more than 100%. All right, everyone good? Everyone, from what I see in the chat, everyone seems to got it. They've got it. Okay. All right, cool. So now I'm gonna erase what I have on the board, get some space. All right, cool. All right. Now, you can also get asked a question about conditional probability. Conditional probability just means something has happened already. So now what is the chance of something occurring? So what I mean by that is they can ask you what is the question is, let me make some space on the top here. Question is, what is the probability, work this out, probability of being a director, given you are coming from the finance sector. All right, this is the question. To work out the probability of being a director, given you are coming from the finance sector. Now this keyword here, I'm going to put this in a block, given. Whenever you see the word given, that is a giveaway, or no pun intended. That is a sign that you need to use conditional probability. All right. Now, conditional probability has its own formula, which you don't need to memorize. I'm going to emphasize that you don't need to memorize that. I'm just going to make some space on this board here. Okay. The formula for conditional probability is probability of A given, and the sign for given is this. It's this dash, or it's this vertical line. So the probability of A given that B has occurred, right, is equal to the probability of A and B, or intersection B, all over probability of B. You don't need to memorize it. I need to tell you that again. You don't need to memorize this formula. You just need to know how to use it and when to use it. So whenever the question tells you given that something has occurred, then you would be using this formula here, all right? Now, the given is the vertical line, and anything on the right of that, well, that is the given event. So in your question, it says given you are coming from the finance sector. So this is your B. Okay, finance is your B. And then the A in the formula would be your director. So your A would be director, and your B would be the finance. All right. So basically, if you read the question, whatever follows after the given, whatever has taken place, right? Which is in this problem, it says given you are coming from the finance sector. So that has already taken place. So it's given that you come from the finance sector. So that is your B. Whatever's on the right of this vertical line, that's your given event. All right. And so once you know that, then you just substitute, instead of A, you put director, and instead of B, you put finance. So this formula now becomes probability of director intersection finance all over probability of finance, because that's your B. Okay, I'm going to pause there. Everyone, does that make sense? Like I said, you don't need to understand how this formula is derived and how we get it. You don't need to understand that. You just need to know how to use it. This formula is given to you. Everyone, before I put in the values in the equation, is everyone good at that? Fantastic. Fantastic. All right. So you have the value. We did all the hard work to get these values. The numerator here, this numerator, we already did it. It's 5.33%. And the denominator, this denominator, we also did that. You worked it earlier, it's 58.59%. The denominator is 58.59%, and the numerator is 5.33%. If you plug it in, your final answer will be 9.09%. Okay, just substituting this for your numerator and then this for your denominator, and you get 9.09%. Okay, is everyone okay with that? All good? Just getting a show. Do you want me to go through that again? If you're lost or confused about anything, please do let me know. All good? Okay. So that's what you can get asked. That's the question. 4 out of 4. 40 gives you the same answer. Yeah. No, Adrian. Okay, that's a very good question that you just asked. Okay, the fraction that you provided in the chat, that is not simplified. Okay, so and you'll get marked down for that. So let me just erase the board. Let me just clear this. So that, yeah, as you asked, you should you raised a good point in the chat. So the probability that you gave is 40 over 440. Thanks. Let me just check the chat. 440. All right. Now, this is not simplified. When I say simplified, it's not the simplest form of the fraction. So here, 40, what, 11. Let's check. 440 divided by 11. Let's see. Yeah, I think 40 goes there once, and I think that goes there 11. Let me double check. Equals 40. And 1 divided by 11. Yeah. All right. So coming back to that, this is, if you had to express it as a fraction, this is what you need to show it as, not this. This is not simplified. All right. But my advice to you is, instead of putting it as a fraction, write it as a decimal. Okay. If you write it as a decimal, you won't get marked down. Sorry, not decimal, as a percent. If you write it as a percent, you won't get marked down. All right. So that's 9.09%. It's also safer because often you won't know whether this is the most simplified form. Okay, your calculator doesn't necessarily tell you that. This is actually the most simplified, but it's going to be difficult for you to figure it out. So rather just punch this into your calculator and write it as a percent. Everyone okay? Does it make sense?
Sorry, can I just ask a question?
Yes,
Is that okay?
please.
Yeah, what I meant by 40 over 440, I didn't mean like that's the answer. I meant that as, calculating the answer instead of the formula you showed us. Because before you even showed the formula, I thought that's where you were heading, and I worked it out, and it came out to the same answer as the 9.09.
Oh, I see
So
what you
that's
mean.
kind of what I meant.
So
Not that would be the answer. After 40 over 440, I meant that that equation gives you the same answer as
yes,
the 9.09%.
yes, that is correct. If you can understand it like that, basically you've kind of skipped the formula and just went one step ahead. Then do it. That's perfectly fine. You can't get marked down for it. But the formula just provides kind of a template and a structure to follow, but it will give you the same thing. So it really is up to you. If you want to do it that way and just intuitively just makes sense in your head to do it that way, just do it.
Okay, all right.
But it
Okay,
gives you the same thing.
yeah, all right, 100%. Thank you.
No worries. All right. So that so now I'm also going to bring up something called mutually exclusive. You see the chat. Will we not lose marks or skip? Kalisha, as long as you got it right, if you got the final answer right, you won't lose marks. But if you skip that step, all right, and if you get it wrong, then you get everything marked wrong. All right? So if I would recommend you use the formula, because at least it gives you a chance to get some marks if you get it wrong further down the line, if that makes sense. All right. So you're also going to hear something called mutually exclusive, right? Now, mutually exclusive means that there's two events that cannot occur together. And if you look at this table, right? So in this table, you can have an occurrence where someone is a director and in the mining sector. So if you look at that, there's 21 of them. Right? There's directors in the mining sector. So if this one circle was directors, this represents directors. And I'm going to let the green circle represent finance. Right? Then they can intersect. So I'm going to color the intersection with a, let me write this as finance. So we know that the green part is finance. So the intersection part, we'll mark it as red, where they intersect here. So this red part is the 21, because you can see there's 21 of them. Now, these events intersect, but you can have a case where, let me draw it. Okay, I'm gonna different color. You see now we have directors again. This is directors. But if you look at this table, you can't have someone who's a director and a manager, okay? Because they're both coming from the same variable. If you look at it, director and manager does not intersect. You can't be a director and a manager, right? Intuitively, that makes sense. So if you draw another circle, that's for managers. Let's put this in green. Yeah, they won't intersect. So there's managers. I'll just write MAN, man, for manager, right? So you can see there's no intersection. So this is an example. The plot that you see on the right, this Venn diagram that I've shown you on the right, this here, this is an example of mutually exclusive events. Exclusive events. Okay, does that make sense? Pause it for a second. Mutually exclusive events, they don't intersect. You can't have both of these events occurring together. Oh, all right. All right, cool. We're almost at the end now. So now what I want to cover in this last part is counting techniques. All right, so counting techniques are quite useful. Sometimes you may use it in the real world. Sometimes you may not. To the board, and I'll explain the example. Okay, so suppose we had 3 letters. All right, keep it simple. It is 3 letters, and the 3 letters are A, B, and C. Now, if the question was basically you had to select 2 out of those 3 letters, right? Then if you could select 2 out of 3 letters, then how many different ways can you arrange them? So, and where the order doesn't matter. What I mean by the order doesn't matter is in if you have A and B, it is the same thing as B and A. So the order doesn't matter. As long as you got the two of the same, they're counted as one, right? So if you look at this one, we just got A, B, and C. Let's try and figure out how many ways can we draw 2 letters from these 3. Well, you can have one occurrence where it's A and B. The next occurrence is A and C. And then the third occurrence is B and C. And there isn't any other way. Now remember what I said, order doesn't matter. So with it CB, it's the same thing. All right. Now, the thing is, it's easy to do it when you just have 3 letters. But when I start increasing that, when I start increasing it, say I have D, E, F, G, then this list goes a lot longer. It's kind of hard to figure out intuitively all those arrangements, right? So you can see here there's 3 arrangements when it's just the 3 letters. But what if you wanted to know how many arrangements there are? So for instance, we have these 3 letters and we want to draw just 2 from them. And the order doesn't matter. I want to know how many different ways can I arrange them. So the way to do it in your calculator is you use something called combinations. Right now, if you look at your calculator, there's a button. It's NCR. Right now, I'll tell you where it is in your calculator. It is above the division symbol. Right. So if you look at the division button, above it, you'll see this notation here. All right. So if you wanted to know to get these 3, just to get the number of arrangements, what you would do is you would say, well, how many letters are you drawing from? Well, there's 3 letters, there's A, B, C, so that's your N. Your N is 3, you have a total of 3 letters, and the R is how many you are selecting from it. In our case, we're only selecting 2 letters, A, B, A, C, so your R is 2. So what you need to do in your calculator is you're going to press 3, then you'll press shift, right? You'll press 3, then you press shift, then you press this division button, right? So you press 3, shift, division, and then you're going to type the R. And you'll see this in your calculator on the display. On the top, you'll see this on your calculator, 3C2. Once you have that, hit equals to, and you'll see you'll get an answer of 3. And that's 3 arrangements you had here. Is everyone following on this? I'm hoping you got your calculator with you. All right. Okay, let me repeat that. Okay. So the R stands for the subset. It's what are you selecting? What is the number that you're selecting from the full set? In our case, we're selecting 2 from 3. So let me start this again. All right. So the question is, you have 3 letters, okay? A, B, and C. So you have a total of 3 in your full population. Okay, so that's your n. Your n is 3. Now, I want to select 2 from those 3. All right, so I want to know how many different ways can I select 2 from those 3 letters. Well, here it is. It's E, that's 1. The next one is AC, that's 2. And the last one is B and C. Right? Now remember, the order doesn't matter. Like I said earlier, it doesn't matter whether it's AB or BA. It's considered the same because it's the same element. So the order does not matter. All right. Now, the question is, I'm not really interested in the actual arrangement. I just want to know how many different arrangements can there be. So there's 1, there's 2, there's 3. All right. Now, in order to get the number of arrangements, shortcut in your calculator is using this NCR. So you just need to tell it what your N is and what your R is. Your R is 2 because you're only selecting 2 letters out of the 3 letters. So in your calculator, you need to input this in your calculator. You need to write 3C2 combination, 3 combination 2. And how you do that is you type 3 in your calculator, then you press Shift, and you press the division button, Shift, and then this, and then you'll see in your display, you'll have a C pop up. The next thing you need to tell your calculator is the R. As you can see for the button, it's NCR. You've given it the N, you have the C, now you just need to write the R, which is 2. So you write the 2, and then you hit equals to in your calculator. And you should get an answer of 3, which is what you expect because you got the 3 arrangements. Does that make sense? All right. Okay. Now, this is when the order, let's open it. All right. So remember, this is when the order doesn't matter. But let's say now that the order does matter. So now, whether you have A and B, I still want to count the case where it's B and A. These are considered to be different. If the order does matter, then you'll have more arrangements because now the fourth one can be B and A. Because remember, this is not the same as that when the order matters. When the order matters, then instead of using NCR, we use NPR. Now, where is this button on the calculator? And that is, if you look at it above the multiplication button in your calculator. So what you need to take away from this is that when the order matters, you use this. When the order doesn't matter, you use this. Right, so let's work out this in the case where the order matters. Then it'll be 3 in your calculator, Shift, then you press the multiplication button, and you'll see P pop up on your calculator, and then your R is still the same, it's 2, and you hit equals to. What do you get? Can you write that in the chat? Yes, yes. Everyone, well done, Kalisha. Everyone following? 6. So remember, when order doesn't matter, then it's NCR. When the order doesn't matter. But when the order does matter, then it's NPR. That's a good question. So, Kalisha, you'd have to use your judgment, and the thing is that you could use it. Let me try and find an example where it's kind of evident that the order would matter. All right, that's a good question. Let me give you an example. Okay, so instead of A, B, and C, right, let's think of this A, B, and C as people. All right, so person A, this person B, this person C, and D. Instead of writing the full names, A could be John, B could be Brad, Chris, right, etc. D, E, and F. Each of them are people, right? They're contestants in a race, right? They're contestants in a race, so there's 6 of them. Right? 1, 2, 3, 4, 5, 6. There's 6 of them. Let's say the question says, this is a contest, and you want to know how many different ways could you fill up the podium. All right, the podium is just, you remember in the podium, you'll only get first place, you'll get a second place, and you get a third place. There's only 3 people that can take the podium. The question wants to know, out of these 6 people, in how many different ways can you fill up the podium? Now the thing is, remember, in your first place, so to say this is your first place, this is your second place, and this is your third place. Right. Having person B coming out first, person E coming out second, and person D coming out third is not the same as having person D coming out first, B coming out second, and E coming out third, even though they're the same people. You can see they're the same people. It's D, D, E, E, and B, B. They are the same people, but the order does matter. Yeah, no, the order does matter. This example, the order does matter because this is what you need to ask yourself. Would you count this and this as the same? And the thing is, you wouldn't, because this is a different arrangement. Even though they're the same people, you're not filling up the podium the same way. Okay? Person D came out first this time. But in this case, person D came out third. So they're not the same. So the order does matter. So you would use N, P, P, 3, where your N is 6. Does that make sense? When the order matters, you use this. And this is the case where order matters because person D coming out first is not the same as person D coming out third, even though they're the same 3 people. But if the question had to tell you, doesn't matter in what order, then yes, then you would use combination, then the order doesn't matter. But they only told you the different ways can you fill up the podium. This is considered different to this. They're not the same. They're not the same. Okay, so the order does matter. This is an example of how you have to use your intuition. Right. And that's what I wanted to cover today, everyone. Any questions? Anything you want me to go over? Can you give another example of when it does not matter? All right, there's an example of where it does not matter. All right, that's okay, so let's say now these letters represent 6 people. All right, so there's 6 people, but I want to form a committee. I want to form a committee. Form a committee of 3 from these people. Right, I want to form a committee. Now, ask yourself this, right? If person A, B, and C are on the committee, is it the same as person C, B, and A in the committee? Remember, in a committee, there is no ranking. You're in the committee or not. When you sit at the board table, right, doesn't matter in what order you were selected. The committee is still the same. So the order doesn't matter here. Got it? Okay. Does it help? All right. You're welcome. All right, everyone, that's it from me for this evening. Are there any questions? Everyone good? Well, I assume it's a yes. I think so, Adrian. I did put that in the chat, but um, let me just double check if I can now. Yes, 13th October, 8 p.m. Please don't wait for the last week. You're actually in a position, if you're up to speed with what I've been on all the collabs, then you're pretty much equipped to do all 4 ice tasks as it is. You're welcome. All right, everyone. Enjoy your evening.